welcome back. Last we discussed about the landscape of Kutch. Now quickly we'll just see that what are the signatures which we got from the Great Run of Kutch and from Dholavira, and how we have correlated our investigations or the findings with the events of the landscape change. So coming back again to the part here, that what we discussed in the previous lecture, we had three deltas of different rivers. One is the Saraswati Delta, Drishadvati Delta, which is this channel or this river is now known as Luni in Rajasthan, and then we had Nara Shatatru Delta, and then further west if you go, you have the Indus one. Now this is what we suggested, and this is fairly acceptable, that when you have the low sea level, then the fluvial activities will extend further towards the ocean, and that's what we consider, that the area which lies between the Thar Desert and then the low shallow sea area was occupied by the extended deltas, and during this period the extended deltas within distributary network had one of the channel which flowed close to the Khadir Island, and this was one of the channels of Saraswati River. So this we had Saraswati, and then we had towards the west we have Shatadru, and then we had Drishadvati. So we suggested formation of delta complex was at around 4 Ka with gradual withdrawal of the sea level. So climate played an important role, which allowed the drainage network extension of the drainage network towards the ocean side, further towards the ocean, which resulted into the multiple distributary network of multiple deltas. So this was around 4 Ka, and this was because of the gradual withdrawal of the high sea of mid Holocene, that was from 6 to 4 Ka. So three major rivers that extended up to the Kutch mainland. This is again a thought process, but yes, of course, this gives some idea about the sculpturing of the landscape. So we say that after this, so after 4,000 years, the tectonic activity was more intense in this area, and that allowed or the reactivation of the fault lines and disruption of the channels and all that along the different faults like Nagar Parkar fault, Luni Sukri fault, Allaband fault, Island Belt fault, and all that. So this was the phase when the tectonic activity was quite intense, which disrupted the delta complex. So 4,000 Ka was your withdrawal of sea, resulted into extension of the rivers and the distributary network, and the disruption at around 3 Ka. Further, this tectonic activities, or maybe we can say the landscape sculpturing, because of the ongoing deformation, resulted into the development of shallow sea outlet in this region. So by that time this region was formed and the delta remained confined to this region, that is the bed zone. That this is known as bed zone, slightly elevated area in the marshy region close to Thar Desert. So this resulted into transgression of the sea, detachment of the Bani. The Bani area is this one actually. This is the grassland which used to be there, but now no more grassland. This whole area is under the salt encrustation. But yes, of course, not salt encrustation exactly, but this part is the salt encrustation. This still exists, but it is not the exactly the grassland now. So it further dissected in the delta complex at around 2.5 Ka. Then lastly, what we suggested was that this, and this is not just based on our hypothesis or the thought process, but yes, of course, in literature it exists that this was connected, this channel, this is Nara channel or Shatadru channel. So this is one of the sketches which are available from Leal 1857 paper publication, which talks about that the Sindri fort before the earthquake and after the earthquake. This was in 1819 Olaband earthquake. So Dholavira in particularly, if you see, is the one of the major Harappan civilization site. That is what we call the earliest urbanization in South Asia. So this is an extremely urban settlement, and even what we felt was that usually we see that there is a cultural transfer from one cultural level to another one, or maybe we can say the one settlement to another settlements and progressively, but there is no sort of a connection or connectivity we see on the people who are staying presently in that region, Khadir Island, and the people used to stay during the Harappan civilization. So there is no connectivity because they were quite modern in advance in terms of their drainage network and all that, but that has not that we can say the culture has not passed on to the next level. So this was the area which used the Indus Valley. Is quite huge area which used to be like in terms of the cultural extent. So you have different phases of the early Harappans right up to the late phases. So this we have. So this is an over conjectural view of Dholavira, which talks about, and of course as the climate changed and the landscape got sculptured because of the ongoing deformation and the climate change. And the final late Harappans, they understood that they will face problems in terms of the water storage and all that. So they had a very good drainage system. So we had an influent, which is the water is coming here and then gets stored into different reservoirs, and this is an outlet of that. But of course they had a very good connectivity. But right now, if you see, there is no channel which connects the city. So this is an conjectural outlay of Dholavira and a very well planned city. So this is where during the excavation, which shows about the well planned streets and shops and houses. So this was one of the example which we got the slumping of walls, and that was because of related to the earthquake, and then waved up walls on one of the side of the gate, which is again example of the earthquake, or we can say the seismic wave which has passed through this area. So a strong seismic shaking has been experienced, tilting of walls. So this is in one of the gate where the wall has been tilted. So these are all signatures which are the left out signatures of past earthquakes which affected this region. And another one which we inferred was that this area was occupied again and again, or we can say reoccupied after the events, and this is well understood by the older construction here, which is seen here, and then this gate, if you look at, was been constructed later on, and you can see the filling of the material here. So this was older one, this was younger one, and then they used the existing or the ruins that existed at that time. Okay. Again, we see some very clear examples of tilting of walls with an offset of walls which have been seen in excavation, during an excavation. So again, another one example of the tilting of wall in that area. This is a clear example of the strong ground shaking. So there were few very clear indicators which suggested that Dholavira got affected because of the tectonic movements in that region. So these are few pictures which were taken by one of the ASI officer, Dr. R.S. Best, who was one of the leading personnel in excavation of the site. Now coming back to this again, what we found was there were a number of active faults which exist in this region, and this faults, one of the faults may be responsible for the damage of Dholavira. So in 2001, after after 2001 Bhuj earthquake, we concentrated in this area and tried to look at the activity of faults here. Okay, but I am not going to discuss this one here and in detail, but we'll just jump to this area because this is more interesting. But I would like to add this here, that this fault, that is in South Wagad fault, we identified two earthquakes which were responsible for the damage to the Harappan civilization here. So I'll straight away go to the Alaband area here and try to show you the site which existed in recent times, that is around 1000 years back, but at present you don't see any like the favorable conditions which allows such settlement to come up here in this region. So coming to the Alaban part, again Alaban terrain is really very interesting terrain in terms of if we see the cultural settlements, and if we look at the landscape, and it is sometimes difficult to connect between these two, but we have tried our best to understand that what might have happened in the past. Now as we talk about the climate change, so major climate fluctuation was the lowering of the mid Holocene high sea around 4000 years, but after that more or less the climate did not get changed in this region. That is what we understand until now, along with some minor fluctuations. So if the climate remained unchanged after 4000 years, then why the landscape got changed so much? Of course, we see a sort of a global warming. We started talking about the greenhouse effect and all that, but during that period, I don't think that there was much of greenhouse effect and all that. So coming straight away to the element, we conducted the field in 2007 and 2011 with an aim to identify the surface rupture. Now this was the idea behind, to understand the pattern of deformation on element, and of course this should be connected to the why the landscape got changed and why the people were being forced to move from that area. So this we have already discussed. Now previous studies before us, which people did, okay, they talk about that there was multiple events, and they looked at the element scarp, the landform, and showed that there were events of liquefaction because of the strong ground shaking during different time. So one was at around like 1100 before present, and another one was 1300 before present. So this 1100 years before present and 1300 years before present. So two events were marked, and this was from Wikiquote area. So we'll be also talking about this region in our studies, that is the Wikiquote, which was one of the major settlement of that time, because it was a well-planned city. They also found some craters, small craters in the excavations, which they correlated usually with the earthquake craters, where, and this again based on the dating of the charcoal, they suggested that two events again around 1000 years, and another one is around these two events during almost like during 885 to 1035 AD, and another one was, so the two samples of the charcoal collected, one from the middle sandy layer and another from the underlying clay. So you have this one, so the sand layers and all that, this they have related from, went from 1890. So this type of studies basically are important when we are talking about the seismic hazard or the earthquake hazard in the region, and particularly when we are not having the surface ruptures. So in 2001 Bhuj earthquake, in Great Run of Kutch, people experienced strong ground shaking, and the formation of the craters were also identified. So what they identified was that during a strong ground shaking and liquefaction, such craters will be formed because of the explosions, we can say, because of the change in the pore water pressure. So pore water pressure increases on subsurface, and it explodes on the towards the surface, or it travels towards the surface and explode or break the surface. While doing so, it also eject the clasts, okay, and that's what we call ejectas. So if you are having the larger clast will sit closer to the crater, and the smaller one will be thrown far away. So within the sand which exploded, you will also see the ejecta. And this is typical of the liquefaction. This we identified in Great Run of Kutch, where the sand dike or the sand traveled or was pushed up, right up to the surface, and cutting through the units on the way of the conduit. So liquefaction feature such a wide crater we excavated this, and this is what we found as the two conduits which connects from the bottom, and they resulted in the formation of the sand block. So the close-up of that, and in between what you see here is the clasts, which are the broken clasts of the soil on the way of the sand which traveled through this conduit right up to the surface. So this is one. So these are all the data which we were collecting, and finally heading towards the Wikiquote site. So we had previous work which talks about at least 2 earthquakes in the region, and then of course it was Wikiquote, but we wanted to do a recheck of this, and then we also did the Alabama studies. So the idea was that how this area or the channel which is coming and just getting lost in the marshland, and what is the total landscape, and so we wanted to understand that, and what is the landscape here. This what we say is uplifted, but if you go and feel and see, it's just a very gentle slope, you will be able to see. Or so what we did in topographic mapping across this one, at least covering the 2 kilometers from south to north. Site A, site B, and site C and site D we collected, and then finally we did this survey at Wikiquote. So this is a landscape which you see from south towards north, and this portion is your 11th area. So this landscape is the uplifted area during an earthquake. So we did the mapping at different sites, and what we found was that the area is of course having some change in elevation, which ranges from 2.5 meter to 6 meters, and then it has a very gentle slope or back tilting towards north, and this is clearly an indication of the ongoing tectonic deformation, because the slope usually has been seen towards the ocean, it's not towards the land side. So this is typical of tectonic deformation, and this was one of the reasons why it didn't allow the Nara channel to flow through this region, because the gradient was inverted. So similar at the another 2 sites we were able to see. So the elevation ranged from 6 meter here to almost like 2.5 to 3 meters on either side. So we chose this area to do our detailed studies and look for the signatures of the sudden change in the geomorphic divide. So this is what you can see as an alluvial fan, very beautiful landform over here, and the drainage which is coming from and getting just having a sharp boundary here. So change in the elevation here, and that's what we also saw in our total station studies. So we did some geological studies and tried to look for some signatures of the liquefaction and the sediments, and this is what we saw. And this is typical of sand blow, as I was trying to show you in one of the slides, which we did the digging in 2001 liquefaction. So this is very similar to that, but this is an old liquefaction signature. And then we have the fault on this portion has moved over this one, and if you want to see the clear signature, the next slide will show that probably, if I'm having. And these are the ages which we have. So events have occurred more or less within 2,700 years to 3,000 years. Okay. Now this is what you see, the clear-cut contacts and the soft sediment deformation. So this block has moved on this one here along this plane, and this is your sand blow. So we have deformed, undeformed layers sequence which sets here. So we did some excavation along this one, and we found these are the trenches, and we found the signature of the earthquake over here, and which dates back to around 2,000 years before present. So we say that this event there was a major event on 11th around 2,000 years. So this probably was one of the events which also affected the Dholavira site. Now coming straight away to the Wikiquote area, this is what we see the settlement here, the main channel which used to flow through this into the Arabian Sea through Corey Creek, but now it just dies out in this marshy region. And then ponding, which I have shown on satellite data as well as on the ground photograph, was from this area. So this is an disrupted channel of Nara and the site Wikiquote. So Wikiquote site is lying or sits on the left bank of Nara channel. So this is the site which we can see here, and fortified the site still exists, and then some reddish color which you see here are the brick pads. So we excavated a couple of trenches in this region to look at what are the signature of past earthquakes. So on surface what we see is this type of the foundations which still exist, and again and north, south and east west orientation of the walls, well planned city again. Now the question is that there was no connectivity of the channel, then why the people came here. So what we did was we also did some excavation, and we tried to understand that what might have happened in the past. So if you look at in this trench, then this is the portion which is like the color variation is very sharp. So this portion of the whitest sand is the tidal deposits. So the cultural level started from here. So people came in and settled down in this area after the deposition of this one, and then so what we identified was that we had like multiple cultural levels, and these yellow arrows are showing the sand layers. Now these sand layers are very much similar to what I was trying to show you, the liquefaction features. So we got 3 cultural levels and more than around 3 liquefaction layers. So we have cultural level 1, then 2 here, and then 3 here. So we did some excavation. Final the foundation which you see here is of the last settlement, which also collapsed, and that we can clearly see over here. So this is one of the best site to study what has happened in the past. So what we found was that the earthquake cycle, or the earthquakes in this region did not just start after they came into or occupied this area, but even before, because the ages which we had of this region is around 1,000 years or so. So the settlements which came in this region were not very old, but during Harappan civilization and all that, this area was not occupied, and this may be the phase out of the Harappan civilization, that is, we can say the late Harappan civilization. But early civilization did not occupy this one because this was not the major attraction. So what we found were that we had like deformed and undeformed units, and these are within so these are again an indicators of the past earthquakes in this region. Then we collected number of samples from this, and this is what we have marked, that we had event 1 here when before the settlement came in from this area. So we have event 1, event 2, event 3, event 4 and event 5. So, and finally these are the ages. So we have the cultural level 1, then we have another cultural level over here, and then final one is sitting here. And further, these are some examples of the craters, which talks about the multiple craters in that area, and cross-secting relationships suggest that at least 3 earthquakes have occurred in this region. and these are the ages which helped us in identifying the events. And also, other than that, if you look at the close-up of this one, then we have the sand blow here, and these are the ejector. So we have crater and we have the ejector. So what I was showing in the group of people who worked in 2001 of the 2001 earthquake, the crater and the ejector, very much similar in this section. Okay. So we also took help from the Archaeological Survey of India, which helped us and in understanding the poetry pattern of the poetry. And finally, what we suggested that this is the preliminary results, and this poetry belongs to a period of 1st century. And our interpretation is that multiple events occurred during 2800 years before present. There was an earthquake in 2000 years back, and Wikiquote suggests events, multiple events during 1200, 1300, 1400 and 1500 years. Reported events from Bet Dwarka also around 2000 years back. And then finally what we did is detailed investigation at Wikiquote was that we tried to look at that how the whole area was been looks like. Okay, so we did a very detailed topographic mapping, and what we found were there were not three but at least 2 gates on each side, that is on east and west, and 1 gate was on the southern side. These were the 2 major gates, G1 and G2, and this were on the west side of the town, and of course this was closer to the Nara channel, which existed on the west of the Dholavira, this Wikiquote. So, and the major settlement or the larger houses were in this area, and the smaller one was this, and along with the shops. So very well planned city, as you see the fortification. So the question was that if the present landscape, we will definitely not allow the people to stay here. So from where they had a fresh water connectivity, and what was the mode of transportation? Of course, the mode of transportation was through channels or the rivers. Okay. So they navigated through the then existing river channels, and so landscape was not the same what we see here now. So in just 1,000 years, the landscape has changed drastically. Well planned city, well construction was been done here, like the north, south, east, west oriented walls. Then you have like double walled or bricked possible drainage, and the brick remains which you see are also suggestive, and even we find some copper coins from this region. So we did a GPR survey, ground penetrating radar survey, to understand that how similar cultural levels exist at the bottom or not. That what we see here is a very well planned construction in this region, and this was just for the understanding we did of that. So I'll end my lectures here. I wish you all the best for the exams, and I hope you enjoyed this course. Thank you so much for being with us. Thank you.